Hello, can you hear me? Hello. Well, can you see the screen? Hello. Can you see the screen? Okay, you're saying yes. Now, let's. Last class we have completed chapter 6. Now we will start new chapter. Its name is internal forces. Internal forces. What are the internal forces? Force. What do we mean internal force? So far, an example, we learned something, some force working out of the body, outside of the body, working outside of the body, right? Outside of the body. Now, what happened? What happened inside the body, inside the member or inside the body? That is we are now. This is the something internal forces. This is the chapter talking about. We apply force from outside. What is happening inside the body, right? What reaction? What is stress? Maybe you don't know this word now. Stress is stress, right? This kind of thing you don't know. So what happened internally? That is internal forces that we will learn now. Okay. So here is a method of section in the internal loading member, chapter objective, develop procedure, analyze forces, study, generate careful support load. Internal forces develop in the structural member. That is we learn. That is important. Chapter of 10. Internal forces developed due to why? Due to internal forces, due to external forces, due to external forces, right? Due to external forces. What internal forces develop, right? Shear and moment, something new. I think you didn't hear before. Did you hear? Shear and moment. Shear. This is very important thing, and we are going to learn this thing. This is what is the shear, and then moment and relation between the distributed load, shear and cable. We will not study this. We will not going to not. This is excluded from our study, right? Right. So what is meant by shear? So first, going to the next slide, I tell you something shear force. Whenever we apply load, you apply load outside of the body, like external of the force. Internal of the body, there is two things start. One is called shear force. Shear force developed. Shear force internally developed. Two things. One thing is shear force, and another thing is bending moment. These two things happen inside the body. Inside the, you apply outside, but inside the body, these two things happen. Okay, these two things happen. All right. So first we learn what is shear force. First we will learn what is shear force. Before I go to the next slide, I explain first. You try to understand what is the shear force, right? Suppose kind of the member. Okay, kind of the member. This is a member. Now you applied some force here. Due to the application of force, this force, what can happen? The cut. So the member can cut. Cut means like this way. Member can cut this way. Okay. Member can cut in this way. The force developed here, the one side, you're applying for this side can be fall down, go down, and this side can be up. So this can happen. This can happen internally, right? Imagine something here, and you applying kind of knife, right? Knife or scissor. You are applying force with the knife, and it is cutting down, and it happened like this. So shear force developed here, is called shear force. Or it can happen like this. You apply some force like this. It can happen some force there, and it can cut it like this. It go upside. Two things can happen. This one thing can happen like this. One side go up, one side go down, and one side go down, or one side go. So this is the force developed here at the surface. Its internal surface is called shear force. So shear meaning of shear. What is meaning of shear? If you see that in dictionary in Arabic or English, shear is the sliding, cutting something. Sliding or cutting something. Right? So the internal force developed, the cutting force, the shearing force, and it is called shearing force developed inside the body, internal body. It's called shear force. Okay, it's called shear force. Now let's go to the example, right? The internal force developed in the structure. So design of any structural member or mechanical member require the material to be used to be able to resist the loading of the member. Okay, this internal loading can be determined by the method of section. Okay, later we'll learn this, right? Now here is the example what I have shown you, like what I have shown you. So far we have learned what thing? If something we put the tension, this is called tension, right? If you tension, so it will cut like this. Example, tension. Okay, it will be cut like this. If you put the compression, so it will break like this, right? And the shear force is like this, right? If you apply force, so one side slide against one side will slide or shear against one side against another part and another side, right? Side part. This is the example of the shear force. Okay, this is the example of the shear force. So these two things we learned before, and this is now we learn shear force. This is due to internal stress, due to the internal force. due to internal force. Now let's see, you see, if you cut some stress, if you cut, there is somebody, now if we cut in the some section, you see the shear force will be like this on this section, shear force, and then the moment will come on later, right? Two things we have to, as I told you, internally two things develop, two things, one thing shear force, one, and number two is bending moment. Now we are discussing about that shear force. Later we will come to the next time. So first we try to understand what is the shear force like. So like here, the shear force usually we show internally. Shear force usually show with the V, usually the V. Okay, usually shown with the V, and see the shear force. If we apply the force 3D diagram, you see this internally force develop here. It is the shear force. It's called the shear force. Okay? If you draw the 3D diagram, it is 3D diagram. So this is, you see the shear force, and this is the shear force. Shear force on the surface. Shear force on the surface. Right? Let's see what is happening. So now some kind of member here, now you cut some section, applied load is there outside, external load, right? You cut a section, so there will be in cutted section there will be some forces, right? So the sliding, this force is called shear force. This is called the shear force. The moment will work. This moment is called bending moment, or internal moment. We will learn later. And if there is any force about the axis, it is called normal force, normal forces, or axial force, So this is the normal force, and any force working in the surface, in this surface, we will say this is the shear force. Okay, this is the shear force, and moment working, this is the bending moment, or internal moment. So let's go there. This how to support, how to analyze, we will learn later. This is we will learn there. How the shear force bending moment. Maybe we'll come to later on this example. So as I told you, the shear force, it is the example at the beginning. I have told you. So some member is applying their force, and then so one side going up, and this is the example of shear here. This is the surface shear force, right? Example. And then this is the 3D example of shear force. Now, what is the bending moment? At the same time, you apply when we apply force, like now, suppose a beam, this is the beam, and you applying. So one thing will happen is one side will try to go up, and another side will go down. The shear force is developed here, right? Develop here, shear force. Another thing will develop there. Another thing is moment. It's called bending moment. What do you mean by bend? Bend means something want to bend like this. Something want to bend like this or like this. Okay, it is called bend. The moment cause to bend. The moment create bending, or cause to bend, B-E-N-D, is called bending moment. Simply, the moment is called bending moment. So some moment try to bend your structure. Like as example here, you apply load, and here is support. So it will try to bend like this. It will try to bend like this. It will try to bend like this. Another example, we have some beam cantilever. You apply load, so it will try to internally. The structure will try to bend like this. Okay. So it is due to the bending, right? It is a bending, something bending. This is also bending, right? Now what create is the moment creating the bending is called bending moment. Bending moment. Example, a bending moment is a measure of bending effect. As I told you, bending effect due to the forces acting on a beam. It is measured in terms of the force and distance. So moment definition we already know. We already know from beginning that moment equal to force into distance. We already know. But in previously we learned the moment is just moment or resisting moment. But here we are learning something is called bending moment, something different. Why it is different? The moment create, you see that the load is applied here and it is try to bending, right? The moment creates the bending is called the bending moment. Now how can create the bending? It can create the bending like this, right? Like as example I have shown you, it can create bending like this. It can create bending like this as I shown you, right? So bending effect can be like this, or bending effect can be like this. And shear force effect can be like this, or it can be like this, shear force. So shear force, okay. All right. So see there. So now bending moment, and what is the positive? Everything we learned, we have two things, plus and minus, positive and negative. Now see, if this side, this is what side? From your side, it is left side. If left side go up and down side, right side go down, we say this is positive shear. Positive shear. If the opposite left side is going down, upside going up, then we say it is negative shear. It is negative shear. It is negative shear. Similarly, positive bending. If it is bent like this, then we say this is positive bending, and if it is shear like this, it is a negative bending, right? As example, if you forget what is positive bending and negative bending, you try to imagine. You drop some water. See, if water is there, then it is positive bending. If you drop water, it fall down, then it is negative bending. Easy to understand, easy to remember. If you forget, like if something like bend like this and you put water, it will fall down. That means it is negative bending. If it is like this, you bend something with water, it will be accumulated here, then it is positive bending, right? And here, if it is the left side go up and goes down, right side go down, then it is called positive shear, and opposite is negative shear, right? Now my question is, I have told you very important concept, right? Now you tell me, you understand or not? Are you clear? Tell me. Are you clear? That's the very big question. Answer me, please. Clear, right? Abdullah Saleh is saying that you are clear. So two important things: bending moment and shear force and bending. Very important thing. Now, this is very important. As I told you, it is very important. Shear force and bending moment. So again, you tell me shear force is shearing the body, shearing or cutting, sliding. All the word you can use. This is the shearing force due to the applied force here. Okay, applied force, shear force, and due to the applied force, this is the force, and or due to the applied force, this is the bending. Two effect here. One is shear force, two is the bending moment. Now bending moment can be two type, from positive bending, negative bending. Shear force also can be two type, positive shear, negative shear, right? Now how to calculate the concept? You will learn concept. We already learned concept. Now how to calculate? Right? Number two, how to calculate. Number three, this is described as a drawing. This is described as a drawing, and how to draw diagram. Actually, how to draw diagram. The bending moment and shear force, this thing actually represent or shown or present in a diagram, Now, so we have three steps. First, concept, we learn the concept. Now we learn how to calculate. Third, how to draw it. Clear? Okay. So shear force, bending moment equation and diagram. There is many things. If you go to read this, it will be confusing. So I will show that directly how to draw them, right? How to draw them. I first show the straight away show the one example, right? How to draw shear force and bending moment diagram. How to draw those things, right? First you okay. Maybe we don't have a space. We'll what happened? Hang. Just wait for a minute. Okay. So I tell you, I need some space. Done. Here and here. Draw shear force and bending moment diagram. Draw shear force bending moment diagram for the shaft. The support A is the thrust bearing, and support B is the journal bearing. Forget about that. What they're saying, journal bearing and support, the horizontal and vertical two component. As you know, you already learned there is horizontal and vertical component. But as I know, you know there will be no horizontal component because no horizontal forces there. So only we have vertical component. Now, sorry, doctor, I think you skipped the example 7.3. Yes, I did. Yes, I did. I know, because the first important is this, right? Important thing is this. Hussain Muhammad Ali. I know I intentionally skipped that one because that is not important at this moment. First, our target is to learn. Our target is to learn how to draw shear force, how to calculate shear force, and how to find the bending moment. That is right, bending moment. Now, if you know these things, 7.73, you can solve the 7.73. If you can 7.3, if you can 7.7, so you can by yourself you can do 7.3, right? Right? Hussain Ali, are you clear? Yes. Now you see what I tell you. Now Hussain Ali, you tell me what is the reaction force at A? Tell me. RA, tell me. RAV. RAV, what is the RAV and what is the RCV? Tell me. If there is a 5 kilonewton force is there. Okay. Tell me please. Anyone? I'll give you some 1 minute or 2 minute time. .5. Okay, Abdullah Nasser is the correct answer 0.5, and RVRC filter is 0. Kamal Ashraf saying 0, but 2.5. Answer is correct. Now, very simple. Very simple. You can know this. You can know this without any calculation, right? How calculation? You know, it is 5 kilonewton, and it's the middle, right? To middle. So it will take half of it, and this will take half of it, right? Easy. But if you say, though, I don't understand, easy. As example, Ashraf here, RAV, RCV in -5. Yes, equation is correct. If you cannot solve, if you don't know how to solve, so I wrote down here. Take the moment at A. Moment at A, anti-clockwise positive. Now things is anti-clockwise positive, right? Anti-clockwise positive. Now remember this moment and the moment, bending moment is different. This moment and bending moment is different. Don't be confused. Different, right? This is the external moment, right? This is the external moment. So if you take the moment point at A, so what else we have? So RAV into 0, because it is going through this, so distance 0. Then we have 5. So 5 is -5 because 5 is rotating. 5 will rotate clockwise. -5 into 2 plus this is R plus RAC. AC, yes, into 4. Yes, correct. Into 4 equal to 0. So RAC equal to 5 into 2 divided by 4, right? So equal to 2.5 kilonewton positive. Okay, so result is 2.5 and 2.5. So easily we can calculate. Now that is not the thing. That is not the thing. The thing is, now we will go to the learn how to calculate shear force. That's more important than how to calculate the shear force, and how to calculate the shear force diagram. Shear force, how to calculate the shear force, how to draw shear force diagram. So shear force diagram, in short, we write down SFD. Shear force diagram. How to draw the shear force diagram. That is what we're going to learn now. Right? Okay, now first we learn to calculate. So we already learned that how to calculate the reaction. We go now reaction force. Look at there. Here. What is there? Shear force usually we show by B sign B, right? So shear force. How to draw shear force diagram? Draw a line like this, and this is the A, it will be now. We need to draw a reference line, 0, 0. We have to draw the reference line 0. Now we have here upward force. Usually we assume plus positive. So point at A, we assume we take the point, this point A. And imagine this point A. Imagine just little bit, just left side. Imagine left side. And just imagine right side, little bit, right? So if in the right side, actually left side of A, there was no forces. Whenever we come to the point A and we found little bit A, and we found there is actually one force is working upward. It is RAV equal to 2.5. So we start from here, little bit, just imagination, little bit there is no force, zero force. From 0 it is now become 2.5. So from 0 plus 2.5, start 2.5, we go upward because it is plus. Okay, then from here to we walk. As example, you are walking. There is no force. You can walk straight away. You walk. So there is no force. You are straight away. You are walking. Just left side of the point, this B point B, left side point B is still you are walking. So just you cross the B and right side, you come to the right side. So what you're finding, so before left side B left, you find this is before left side you got 2 plus 2.5. Just you cross the B, and come to the right side, and you found that is plus 2.5, and you found, well, there is a one force working 5 minus downside is minus, so you get the minus 2.5, right? Left side, just left side, you had 2.5 plus 2.5 and just you cross B right side, and you get that this is minus, and you get minus 2.5. So we are going the minus 2.5. Okay, minus 2.5. Again, imagine you are walking because nothing is there. So minus 2.5. Walking, you keep walking, and you see just left side. Imagine you have minus 2.5. Okay, now minus 2.5. Just you cross to the right side, BC right side. What you are getting? Minus 2.5, and you are seeing that, well here on the right side, little bit right side, we find there 2.5 plus 2.5. So plus 2.5 equal to 0. So from minus 2.5 to we go to 0. We go to come here 0, and after that nothing we have, so we stop here, right? So what we got, automatically we got some diagram, and this diagram, so this is the 0. So upside is plus, we know always. So this is the positive side, this is the positive side, and we draw like this. And this is the negative side, we write down minus, and like this. Okay, like this. So what we got finally, we got this shear force diagram. Right? Clear? This is the simplest example of how to calculate shear force and how to draw shear force diagram. Now you are going to tell me, you understand or clear or not? Can you repeat, Hussain Abdul? Yes, of course I can repeat. I will repeat because this is very important, right? This is very important. This is very important. The next example we'll do or you will do will be more complicated, right? Okay, so I open another new one. So question example, what is the question, right? In quiz or not quiz, in the final or everywhere, the question will be, what is the shear force? Just we'll write down, draw SFD and BMD, right? Bending moment diagram. That's it. We will write. Question is very simple. Now you have to do it. Now here, try to learn. I am repeating it now. Finally, always said, can you repeat? Yes, we are repeating now. Tell me, before that you tell me, you know that how to calculate RAV, that means a vertical force AV 2.5, you already calculated, and you calculated RCV equal to 2.5 Newton, and here how much distance? I don't know, maybe 2 meter, and here is 2 meter, right? This was our beam, right? This was our beam, and they also can draw the shear force. First shear force diagram. First is shear force diagram. Okay. So first shear force diagram, you have to first calculate the reaction force. We already calculation force. So diagram to draw, follow this procedure. First, draw a line, draw a reference line. Pen, pencil, scale, ruler, whatever you use, right? You use, and this is the reference line. 0 and 0. Reference line, any reference line use always 0, 0, right? If you draw the Cartesian coordinates, 0, 0 starts. This is the 0, 0, right? Now we start at 0. Start at forces at 0. Now after at 0, imagine like this. After at 0, after, so it must have to start with 0. Why it is 0? Like A, B, C. Now suppose you are walking, example, you are walking through, start to walk from here. You are a person, you are start to walk, right? When you walk, and there is a load on your head, right? So when you walk, before you reach to the A, you have no load on your head. You have no load, right? You have no load, nothing. Your head is clear before you reach to the A. So you start with 0. You start with 0, or otherwise we can say at A, at point A, left side. We can say point A at left side. This is here left side of A. Before entering to the beam, put your leg on the beam, a left side, on your head there is no force, 0. So just left side on your force is 0, right? Whenever you enter the point A, that means imagine just a right side, you find there is 2 upward force. Now you go up 2.5, okay, 2.5 kilonewton. Then you are keep walking. There is no on your head, there is no burden. You keep walk and keep walk. Just before entering point B, BL, VL. How much you have? Still you have still before VL, V, this is VL equal to VA was 0, VA right was plus 2.5, VB, you arrive to the point VB left, usually write like this, VB left. Still you are working with the burden 2.5, still you have 2.5, right? Whenever you just cross the right B, you just cross the B and reach to the just right side. Okay, imagine right side. Whatever you got right side, it was plus 2.5, but now extra burden on you come minus 5 because downward minus 5. So what resultant you have at the end? You have 2.5. So at the V right side, V left side 2.5, and V right side, when cross the B, you have minus 2.5. So you cross the B and minus 2.5. Okay. Now here, the left side and right side is just an imagination point, right? Imaginary. Practically, you will not see. So you will be here, and be here, right? So minus 2.5. Practically, it is not visible, but just imaginary. You have the this is left side here and right side here is 2.5. Okay, minus 2.5. So you go there and minus 2.5. There is no force there, so you keep working, and just entering before the C. What is happening before entering C? So before entering C, you have minus 2.5. Coming with minus 2.5, right? Then BC R, when you come in the minus, just cross the C. That means right side. So 2.5. And when you cross the C, you find there is another force, upward force is applying on you. So you get the when C, you find the finally you got the 0. So 0. So from here, the minus 2.5 at the left side. Whenever you come to little bit right side, you find that 0. So you have to go up to 0, right? When you reach the 0, after that you finish. You come out. Your job is finished, right? Okay. Now your drawing is automatically drawn, right? Automatically your drawing is finished. Now upside is positive, downside is negative. So you draw it and you just draw it like this. Some hash or hatch. Your shear force diagram is complete, right? So it is positive shear. Yes. Answer is yes. It is positive shear. It is yes. Okay. Now clear how to draw, how to calculate shear force diagram? Here, tell me. 29 টাকা। Okay, so today is not working. Fine, if it doesn't work, so we don't use it. Now tell me, you understand or not? Tell me. Yes, clear, right? We'll do some other example, more complicated example. Hopefully those will be those will help you more to understand, right? Now now we will learn bending moment diagram, how to draw the bending moment. Now how to draw the so this is calculation is if I'm showing this is, you can do the calculation or you can draw directly the shear force diagram. A bending moment diagram, how to draw the bending moment diagram, right? Again, one way is you can calculate bending moment. Now bending moment, right? One you can calculate, one you can calculate, two you can draw, both. So I show you now. There is no space, but no problem. I show you how to draw it. Both way, two way I will show you. One is the calculation and another is the straight way. So here was our beam. Our beam is was like this. And we have drawn shear force diagram is like this. Okay, this positive, this is negative side. 0 0 2.5 2.5 minus 2.5 minus 2.5. This was our shear force diagram. Now we write down SFD. Okay, like this. Now we will draw the bending moment diagram. Similarly, and draw another line. Continue, and draw another reference line, 0 and 0. Here we will draw the bending moment diagram. Now, using the diagram, first is using the diagram. Using diagram, we can draw two way. Using diagram, first you can draw BMD, bending moment diagram, from the area of shear force diagram, using the area of shear force diagram. Straight away you can draw it, right? As I told you before, at the beginning point there is no moment at point A, B, and C. Just moment, bending moment at A, left side, 0. There is no moment. And what will be the bending moment? Don't ask me any question. Just see what I'm doing, right? Later I will explain. So here at 0, we start with 0. Now bending moment. Remember, bending moment. I write down what and write down. Keep note. Pen. Bending moment equal to area of shear force diagram. Very important. Remember this. Keep note. Write down in your paper. Bending moment equal to. So, doctor, can I go because I have test now before you? Yes, you can go. You can go anytime. No problem. If you don't come, I don't mind. Bending moment. Now, bending moment equal to area of the shear force diagram, right? Shear force diagram. So here is 0, and we'll go that point. They start at 0. Start at A, and there is no force. We have point at B, so we reach B. Where we stop here. Where we don't know. Where we stop? We learn. How we do? We'll do as a area. So what is the area? Area is 2.5, and here the distance is 2. So area is 2.5. This 2.5 into 2 equal to 5. So this is kilonewton and this is meter. So our kilonewton meter. So from 5 we will go there, 5 kilonewton meter. Okay? And we will connect like this. Connect like this. If our shear force diagram is go the horizontally, our bending moment diagram will be inclined. Okay, and their result is plus. So we write down here plus, and we go upside plus. Okay, then we are here, right? We are here. So just where we plus, so we are at the bending moment at B, just to the bending moment at B, we have the plus 5, right? Plus 5. What is the bending moment here at this bending moment? Because it is the what is bending moment here? Again, the area. So we have plus 5 here, plus 5, and plus 5, and this area. Now what is the area? Minus 2.5. Into distance is 2. Into distance is 2. So what do we have? What is plus? We have 0. Where at this point? At C. So we will again we go like this. We go this connect. Sorry, this line is not clear. How we draw it? draw like this. My handwriting is not, drawing is not good, so we will draw like this. Okay, connecting A to connecting connect like A to C, right? A B to C. How to connect? It's a straight way connect a straight way. So like this, I cannot, somehow I cannot draw it. Okay, I don't know why I cannot draw it clearly. Okay, so 5 and 0. So this is also positive. So this is our bending moment diagram. This is our bending moment diagram. Okay, this is bending moment diagram. All right. Any question? Tell me, please. Today time is up. I tell you just you also stop here. Next class we will explain more. Class will be explaining more. But this is at just as a initially starting, right? Initially a starting point. So here you see the drawing we have done similarly already done here, already done here, positive, negative, and what we have told you is like this. Maybe they have done a different way, no problem. Answer will be the same at the end. So I suggest you follow this and watch what they have done, how they have done. Next class we will do it again. Okay. Any question? Please tell me. Time is up, so you can leave, or you can ask me any question if you have any question. Tell me, please. Any question, please?
Doctor,
Yes, tell me.
Yes. In chapter 6, we didn't take 6.8 and Friends of Mechanics, so it's not with us?
Chapter 6, tell me. 6 point.
6.8.
Tell me. Example 6.8, yes, no, finish. Where I finish is finish. Why stop up to that? No need that those 3D. It's a 3D or space type. Space is not with you, yes?
Yes, okay, thank you.
Okay. Well, if you don't have any questions, so we can leave. You can leave this class. We can also leave and see you next class. Okay. But review what I have teach you. It's very important, right? If you have any question, you ask me.